So welcome back to the fourth lesson of our appendix here. We're going to continue on with the topic of integration by parts. This will be part 2, where we deal with repeated integration by parts. You're like, what? We got to do it again? Yes, you do. And also integration by parts involving definite integrals. And that's example number 2. All right? So I hope you remember from last day that we had an acronym to help us figure out the two different parts of the integration by parts. Remember U, and then we had to find du, dv, then we had to find v. The acronym was LIPIT, I think, if you remember properly. We looked for logarithms to represent u. Don't see logarithms here. I looked for inverse trig. Nope, nothing here. I look for polynomials. Yes, I do see something here, x squared. And so the other part that's remaining must be sine 2x dx. Now once again we can do this because we see this is a multiplication of two things. Now let's go ahead and find du. Yep, that's 2x dx. And v, the integration of sine, yes, it's negative cosine. Don't forget, the extra factor of 2 we need to remove, so that'll put a 1/2 in front. And now you're set, because I can now rewrite the integral of, that didn't look so nice. The integral of x squared sine 2x dx as, remember, it's uv, ultraviolet, u, x squared, v, negative 1/2 cos 2x, minus the integration of v, negative 1/2 cos 2x, times du, which is 2x dx. Okay, let me just try to rewrite this a little bit nicer before we move on. Two negatives become a positive. The half times the 2 is just 1, so that's great. I have here now the integral of x times cosine of 2x dx. Do you see now why we say this is repeated integration by parts? Because what do you see? Another possible integration by parts question. What do I let equal to u? And what would you let equal to dv? That's right, x must be u, another polynomial. Du is very simply just dx, that's great to see. dv must be everything else, that's cosine 2x dx, and v would be 1/2 sine of 2x. Alright, now we're ready once again to do integration by parts. So it's uv, so x times 1/2 sine 2x. uv minus integration of v, 1/2 sine 2x, du, which is dx. Now don't forget, we still have this term from what we had from above, negative 1/2 x squared cosine 2x. That is also still part of my solution. And now I'm thinking we're getting close to the end, because I'm just going to copy out those first two terms again. Nothing needed to do there, but the integration of 1/2 sine 2x, well, that 1/2 is a constant. I can bring it out. The integral of sine, of course, is once again negative cosine, and there should be another factor of 1/2, and then don't forget plus c. So ultimately here, negative 1/2 x squared cosine of 2x plus 1/2 x sine of 2x, and then plus 1/4 of just regular cosine 2x, all plus c. There you have it, your answer to the integral of x squared times sine 2x. And like I said, if you wanted to double check this, take the derivative, and hopefully you get the same thing. Okay, alright. Our last example here then will be taking an integral using integration by parts with, of course, limits. Hello, definite integral. So ultimately it's the same idea. We just do the antiderivative, then we have to evaluate. So here we go. What do I let equal to u? What do I let equal to dv? So remember, in this case, I'm looking at limit once again, and I see logarithms right away. That must be u, because I can't let that equal to dv, because I have no idea what the integral of natural log of x is. At least it's not too simple. You can probably find it out on the web if you wanted to. So ln x is your u, so that means x squared dx must be my dv. Now I can quickly go ahead and find du. Do you remember the derivative of natural log? I hope you do. It's 1 over x dx. And the antiderivative of x squared, that's x cubed over 3. So here we go. Okay, let's just ignore the limits and let's just quickly find the integral first. So the integral of x squared natural log of x dx will be equal to, here we go, u times v natural log of x times v x cubed over 3 minus the integration of v x cubed over 3 times du 1 over x dx. I'm going to simplify this by putting the x cubed over 3 in front. And then here with my integral minus, this will become a 1/3 in the front. And I'm left with just x squared dx. And I can then quickly go ahead and continue on taking the integral of x squared. That, of course, is just x cubed over 3 again. I could put a plus c here, but remember I'm going to be now looking at doing it with limit of 1 and 3. So let me just quickly simplify. And now, if you think about it, I need to evaluate this whole entire thing. So I could just go back and put in 1 and e, right? Which means this whole thing isn't evaluated from 1 to e. And I can just do that for everything. 1 to e, 1 to e. And let's simplify this to 1 to e. And now we will just evaluate. So that's e cubed over 3 times natural log of e, which happens to be 1, minus 1/9 e cubed, minus, and then this will be 1/3 times natural log of 1, which happens to be 0, minus 1/9. So if I want to simplify this, e cubed over 3 minus 1/9 e cubed, and then plus 1/9. And if you want to simplify just a little bit more, I think we can combine these two terms together. They are both e cubes. I can rewrite the first one with a denominator of 9. So this just becomes 3/9, right? So 3/9 minus 1/9 become 2/9 of e cubed plus the 1/9 at the end. And now we have evaluated a definite integral using integration by parts. That's it. Take a look at assignment A4 if you can, and enjoy.